Okay, welcome back. Um, we are now here for part two of contextualizing exponentials and logs. This is just a continuation from Unit 2, Activity 2. Scrolling up just to show you. Last video, we kind of left off. We did a warm up and kind of talked about full time equivalent students that were increasing. And for problem two here, let's take a look at it and talk about what happens if the college had to decrease their units because I don't know, maybe we didn't have enough funding to get enough teachers to teach all these courses, or maybe we had to decrease the amount of students we could take because of and what's happening right now with health concerns around the U.S. and or even if we couldn't find rooms for things. So if we had to decrease our full-time equivalent students, again, I'm just referencing the fact that you're familiar with the first problem, number one. But this time, instead of increasing, you wanted to decrease by 6%. Remember, my growth factor, B, is 1 plus a rate. And what kind of a function we're going to use is dictated by the fact that there's a constant percent change. Again, that means not linear. And we compared those, I don't know, a couple sessions ago. So we know that we're using y equals ab to the x. And we could go ahead and calculate these values of 8,000 if we wanted to. But what would we, if you're losing 6%, what would our multiplier be? So our rate, we want to take away 6% or 0.06 written in decimal form. And that's going to be, I think, 0.94 or 94% of the original amount. So if that's what you're going to do, just like the last example, we could take 8,000 if we wanted to fill in this table and times it by 0.94, and that will give me 7520. You're always welcome to pause the video and see if you can get ahead of me too and practice. Might be a good idea at this point. Might as well just, you know what, try it. Try to complete the table for A and do part B, and then come back and I'll see if you can match your answers up with mine. So pause the video and fill in those other three blanks and do B. Okay, if you're back and you multiply the new number, 7520 by 0.94, 7,068. And if I multiply that by 94%, in other words, you lose another 6%. I think it's 6644.6. I'm running out of room here. And the last number should have been 6245.99 or something like that. So if you're filling out the table, those are the values you should have. And remember, initial value, growth factor. So if you wanted to find an equation in the calculator, my initial value start out with 8,000. And every time I'm multiplying, remember in this case, it's less than 1, so you're decreasing. So your formula is 8,000 times 0.94. Now the question for part B says write an equation for the function and then use that in your calculator to estimate when it's only, in red here, 5,000. So if I wanted to do that, let's see if I can get my calculator up for you guys. Sorry, you guys can hear my dogs walking around in the background, I think probably. And let's go ahead and plug in our first function, 8,000. And you need to practice this for the exam so when you're doing this, it's not foreign to you. So 8,000 times 0.94 to the power of x. So there's your first function. And if really the question on the table is when is it, and I forgot the question already because I'm sitting there paying attention to my dogs as I shouldn't be, but they're distracting, so I'm sorry. But they wanted to know when is it down to 5,000 full-time equivalent students. So 5,000 is my number. And here we go. So there's two functions. And if check it out, if I just graph them again, depending on what window you have, it might not be all that helpful. So you do have, as we've talked throughout the semester, other options. I didn't know if you knew about this one, Zoom Fit. Sometimes you can have your calculator guess the right dimensions. And let's see, oh, it works this time. So either way, and I'll show you just for, if that didn't work on yours, you can check out the window with the computer generated. And notice my y value over here is 100,000, or excuse me, my scale, but my y max is, oh, it looks like 10,000. Okay, I don't know why they have a scale of 100,000. I couldn't explain that to you forever or at all. But x is going from -5 to 100, y minimum 16 going to a maximum of 10,000, and your graph looks something like that. Now remember, the graph that'll help you, my dog is still rolling around. Sebastian, sorry. You could find out when that's actually going to hit 5,000 by hitting second and calculate. Remember, we want to find those intersections. And even if you know how to do it by hand already, it's good to be able to do this graphically. So hit enter, enter, and the third value, guess, hit enter one more time. So those two values, or they will get full-time equivalent students of 7.59 years later. And you see what I'm looking at. Hopefully you see I'm looking right in here. Okay, and there's my value. That's time, and this was when the blue line will eventually go down to 5,000 full-time equivalent students. Okay, so put that in your answer, 7.59. I'll come back here and do it myself. So if I wanted to figure out when that was going to be 5,000, that's how it looks algebraically. And I think we solved x was 7.59. Now, if you already know how to do it by hand, I would suggest you go ahead and move the 8,000 over. You could fool with this function if you want by hand, and make sure you could show your work, because that's how you get an exact answer. Okay? Now, let's do another one. Number 3 here on the next page. Consider these two functions. Tell me quickly, and this should be quickies, which ones model growth and which ones model decay or decreasing. Can you tell me? And if you're looking at it, that growth factor is bigger than 1. So that's growth. And this growth factor is less than 1 at 0.93, so that's decreasing. And we've done that a bunch, so that should be familiar. Let's see, I think that's about it. We know what's going up or down based on the fact that it's growing over 100% or less than 100%. And I think that's about it. Notice they both have as well the same initial value. So one's going up, one's going down. Okay, your turn. Pause the video and try to do problem 4. And when you come back, I'll do it with you. See you soon. Okay, so if you're back, let's go ahead and take a peek at this one. So they're asking you to find an exponential function for the data in the table. And the main reason I was trying to get you to do it before me is just see what you come up with. And if I'm looking at that thing, remember, they're telling us we want an exponential function. That just means this: initial value, growth or decay factor to some power. Now, right off the bat, you know, excuse me while I erase that, we know our initial value is right here. And I know I'm writing up here a little bit, but let's just put that initial value in there before we even get going, 500. And then I have some growth or decay factor to some power of x. Now, what you should be telling me or yourself in your head right now is that increasing or decreasing, first off, going from 500 to 300 to 180 to 108 to 64 and so forth. Increasing or decreasing. And hopefully you're telling me it's decreasing. So the other trick to finding a growth factor a lot of times, as I'm over here on my calculator checking my work before I suggest it, is to take one y value and divide it by the preceding y value. So if I clean this up a little bit, I know I have a decreasing function, but if all I need is my growth factor in here, you can do that And this only works as long as it's sequentially. Notice how I'm going 1, 2, 3, 4. As long as you're going up in equal increments, you can always take the y value ahead of it and divide by the preceding to get the decay factor. So it's 0.6. And a way to test if your whole function is exponential, remember we did one this test for if it was linear before as well, but if this whole thing's exponential, then every value divided by the preceding value will be the same. And is actually the case. So 108 divided by 180. But here's the thing, if they're going to tell you to find an exponential function, you don't have to do all that testing. So really my function is 0.6, and this is it. So let's see what they ask for in part B. When the growth factor is a decimal, we explain the change as a percent. What is the percent change in the table above? So what would you tell me, or the rate? That's what they're really asking you for. So notice it's 60% of the original amount, but I've been showing you this the whole time, b equals 1 plus an r. And in this case, if you knew that the b was 0.6, remember 60% of 100, what's left over, if you can't see it in your head, just do the math, and I think over here you're going to get negative 0.4 equals the rate, or if I move the decimal, it's decreasing by 40%. I'm going to ask you that on the midterm or the final, probably both. So you're going to have to be able to figure out what's that percent change. I'm going down by 40% each time. Or you could say, I'm taking 60% of the original. Sorry, it's a little sloppy there. Okay, so let's do one more. For number 5 here, consider the equation y equals 5 times 2. And let's go ahead and put an x up here. I have a feeling it's supposed to be there. So that function models a quantity that's doubling. So even though the growth factor is a whole number, we can still describe the growth as a percent change. So same question, what's the percent change? Remember, b equals 1 plus an r. If it's 2, and I might have done this in a previous example, but it's okay to revisit it, 1 equals my rate. Now, what is 1.00? If that's my rate, and you should be telling me it's 100%. And because it's positive, the way we'll talk is the percent change, it's increasing by 100% each time. So when you go into a casino, if those of you that gamble, you were to go in with $100 and you walk out and you say, I doubled my money, really you come out with your $100 and then you come out with 100% more, or 100% of what you came in with. So that percent increase, you came out with 100% more than you had to begin with. Got it? Hope that helps. Well, in this video here, keep going. I will encourage you to go ahead and read ahead in the notes here for the group problems and so forth, so that you can see what we're going to do in the next video before we actually do it. Okay? That's good for now. We'll talk to you later.